Well, one look at this and you know we're back to the scorching summers of the 2000s and 2010s. Blue sky everywhere, and I think we're getting into a drought pattern. Very mild one, but you can see it starting to settle in across portions of central Texas, and they're definitely getting it pretty bad between Amarillo and Denver. Severe drought shown in that area, and that extends back through the Great Basin into the higher elevations of Oregon. The surface map for the southwestern U.S. this afternoon shows a cold front moving through the Central Plains. Temperatures coming down into the 60s and lower 70s in the High Plains area. Down to the south, we've got the dry line on the move, and a dry line bulge indicated right there around Childress. You can see the dew points at Childress are down to 49, but you go north of there and they pick up to 64, even in Guyman 64, and you go south of there and they come up to 56. We got the heat low centered across Kingman, Las Vegas, all the way up into the deserts of southern Nevada there. 96 at Las Vegas with only a 6-degree dew point. And I'm noticing one of the observations that came in the last few minutes has it down to -5. Is that even valid? That's crazy. Let's look at Nellis Air Force Base. And yeah, it does look like something's happened there. The dew point fell from about 30 degrees Fahrenheit all the way down to 4 Fahrenheit. Huge, huge drying taking place in the Vegas area. And another way to check on that is to look at the high-resolution rapid refresh. And we can see that dark beige color in there. That's where the model has the dew points coming down to the single digits. What's the origin of that? Not really sure. I'm sure the precipitable water is pretty low, and there's probably a combination of that with some strong subsidence taking place in that area. But you look to the south, look at how the precipitable water comes up from 0.5 in the Vegas area up to 1 inch and maybe even 1.25 inches around the Phoenix area. So the moisture is returning into Arizona, and we'll see an increase in monsoon activity over the next couple days at least. And you can really see it there on that plot there, 56-degree dew point at Phoenix and 55 at Tucson. Let's check out some soundings. For the Phoenix area, forecast sounding still showing somewhat of an inverted V, but the moisture has about 100 millibars of depth. The main problem, though, is mid-level temperatures are pretty warm, and that's contributing to the depressed capes in that area. You can see the convective inhibition is solid. That's keeping anything from developing. It's pretty strange, you know, we get the moisture finally in the deserts, but we have poor lapse rates and a lot of warm mid-level air. So we'll have to see what happens over the next few days, see if we can break that down any. And there's a look at the current satellite picture. Yeah, it's clear as a bell out there in the southwestern U.S. Got some mountain wave activity over Colorado and some Lee Mountain cirrus right in that area there. That could be a passing shortwave moving through the area. And right in here you can see some low cloud. This is stratocumulus and stratus. Usually when we see that, especially with that U-shaped pattern, That would indicate a front coming from Canada through that region. And out over Texas, this sure looks like convective debris, probably from some showers that popped up over New Mexico or West Texas. And that's what you saw in the opening clip here just a couple minutes ago. And then, of course, out in Arizona and New Mexico, moisture coming together on the mountains, helping to produce some showers in that area. You get that moisture transporting up to the higher elevations, and that makes it easier to get the convection going, not so much in the valleys. So as the monsoon starts ramping up, we should see the storms forming mostly on the mountains and then more of it in the lower mountains, and then eventually some of it breaking off into the valleys. The northwestern U.S. not seeing much weather. They're under the influence of this high pressure 1020 millibar high over the Bitterroot Range and another segment of that high over the Black Hills. And this is forming kind of like a very large ridge extending from the Pacific into the northern plains. South of that ridge, we do have a slight northerly component to the flow. And north of the ridge, we have a slight southerly component. Don't really see it much due to the influence of this very strong low up there in the Hudson Bay region, but the westerly component is really what's noticeable. And in Saskatchewan, winds up to 30 knots in many areas with this unseasonably cold air coming out of Alberta and the Northwest Territories. Satellite picture, likewise not showing very much. This cumulus here in the lower elevations of Montana and western North Dakota is characteristic of cold air advection. This has a very strongly diurnal cycle to it, so we should see that kind of dissipate later tonight and possibly redevelop further south tomorrow. A little bit of deep convection developing in some parts of South Dakota there around, I guess that'd be Mobridge, and on the higher elevations of Wyoming. And then down to the south, of course, we can see that mountain wave activity, which clues us in to where the jet stream is. That and this cirrus pattern that you can just barely see in there. This would indicate possibly a jet streak in this area, or maybe a little bit further east. It might be on the tail end of that. For the northeastern U.S., I think a good place to start with is the satellite imagery. Two prominent systems we can see. One is the baroclinic leaf pattern over Minnesota and Wisconsin, and let me paint that out. That's going to be up in this region right here, and you can see on the backside the very strong, well, can't see it too well. Let me move this over. But there is some strong subsidence trailing this system, and then the main baroclinic shield pattern is kind of right in that area there. And this area of congested overcast cloud, that would indicate a possible warm front, and so I drew that in there on the surface analysis. Across Ontario and upstate New York, looks like we got some northerly flow right in that area there. You can see that those clouds coming down, approaching Lake Ontario, cooling and dissipating, and then developing on the other side as they pick up surface heating. So we go further west and we try to find the actual ridge, the high pressure area, because we're going to hit that before we get to this low. And I would guess that would be kind of in this area around Lake Huron. And once we go west of there, we get into the southerly, warm, moist advection pattern. Okay, out of New England, looks like there's an upper level low in that area. I think you probably picked that out. Over New Hampshire, and the clouds, they kind of spin around that low, and we've actually got some cold core convection in there. And those, likewise, like on the northern plains, those are strongly diurnal. So we should see that taper off as we get into evening. And then the main frontal system, you can probably see another baroclinic shield pattern way out there on the right. That's going to be our main frontal system, so we're going to expect to find the surface fronts way out in that area. And if there's anything in the New England area, that's going to be an occlusion. And there's our surface chart. and not much to see there because this is mostly an upper level system. But in New England, yeah, there is a occluded front in that region. And then moving out to the west, we pick up that high pressure that we inferred in the Lake Huron region. And then we go further west, we get into that warm, moist advection pattern. You can see the southerly winds there, the dew points are up into the 60s, and we pick up that warm front in Wisconsin. And then that brings us to the southeastern U.S. Satellite is a good place to start, and I'm looking for boundaries. You know, we should see them in the southeast this time of year with the air mass thunderstorms, but I don't see much of anything. If they're there, they're very, very small scale. I see what might be something in here, but I don't know the exact orientation. Then looking out in Texas, it is pretty clear. We pick up that mid-level debris, that altocumulus patchy cloud across the area, but other than that, not much to look at in that region. So let's go to the surface map and see what we got. So I went ahead and put this little weak stationary front, probably decaying, from the Carolinas into the central Georgia and central Alabama area. And to me, that kind of divides this hot 95 over 75, 95 over 60 from this cooler upper 80s temperatures. I'm not 100% sure that's there, but we've seen something lurking in that area for the past several days, and that could be it. You can see the pressures are kind of low in there. We go from 1018 down to 1015 and then back up to 1018 to the north. So this is actually coinciding with the trough. And when we have a trough in place, that's a favorable pattern for convergence and helping to heighten the temperature contrasts. Now, maybe I should put just a regular stationary front in there instead of a dissipating one. But what we've had over the past couple of days has not really gained much steam. So I'm going to leave it as a frontalis Caesarea for now. And then out in Texas, I think a good thing to watch is the moisture return. Mid-70s, where are those going to be? I'm going to draw an isodrosotherm for 75, and that's going to come up kind of like this here. Wow, it's even getting pretty humid along the central Gulf Coast. And let's see, 75 out to Orlando and Vero Beach. And then we curve that back. So that's the 75 isodrosotherm. And then maybe 77. Yeah, it's going to be in here. It looks like the really heavy moisture has shifted a little bit east. And we find Texas back to seasonal levels of low 70s and upper 60s. So we've gotten some relief here in Texas. Definitely not like a couple of days ago where we had like lots of places over 100 and dew points near 80. And let's take a quick look at Hawaii. So Honolulu is going to be kind of right in that area there. And what we see here is the trade winds. A lot of low clouds moving from east-northeast to west-southwest. And we see a little bit of high cloud moving the opposite direction. So the atmosphere is sheared. Could be a favorable pattern for stronger showers and thunderstorms if we had any instability, but I'm not really sure that we do. Let's see if we can zoom in on some of this stuff. Subregional sector, yeah, let's give that a try. I bet that's pretty neat. Got to remember we have two massive volcanoes. We have one here, and I can't remember the names offhand, but they go up to about 13,000 feet. So you have a pretty huge barrier effect leading downstream from those peaks. And you can see on the upwind side, you have lift. So that side of the island is pretty cloudy, and then on the lee side, it's pretty dry. And a lot of the other islands are like that too. See how it's kind of wet on this island and kind of dry on the lee side. And same thing going on as you go north, and yeah, especially up here. And for our astronomy calendar, all eyes are upon Neowise. And that's a comet that rounded the sun several days ago and is now springing back out into the inner and later the outer orbits of the planets. And this is what it's going to look like this evening, actually tomorrow evening, but the same position is going to apply. It's going to be just above the setting sun and off to the right, and you want to look in that direction. Best time to look is after the sun has set, and if you can see the horizon, maybe close to twilight. So check that out. And now it's time to look at our geography moment. The Cap Rock. What is that? Well, the Cap Rock is a feature found in Texas, in the Panhandle, and out in West Texas. And we'll look at the map here. And you'll notice we have this feature called the Llano Estacado. And this Llano Estacado region marks a very new region of alluvial sands and soils that resulted from erosion of the Rockies, and it was kind of deposited in that area. And it's surrounded by this region of much older Permian rock. It's very rugged out in that region. And so this area here is used mostly for grazing. It does get flatter out towards Oklahoma, so you can get some farming out in that area. But when you go west into this red area on the Llano Estacado, a lot of it is cropland. A lot of cotton and watermelons and stuff like that are grown there. And of course, some ranching operations. That's the Cap Rock right there. And that marks the division between the Llano Estacado and that older Permian terrain. It effectively acts as a steep region of hills, so when we get the moisture flowing up north from the Gulf into an area where we have severe weather expected, we get some extra lift around here, and often we'll get storms forming along or just to the west of the Cap Rock. And y'all may know Tim Marshall. He's one of the early tornado chasers. His thesis paper was on the role of the Cap Rock in the Palo Duro Canyon and its effect on precipitation in that area. And that's all we have for this afternoon. If you enjoy learning about forecasting and meteorology, pick up a book or a software tool at our website, weathergraphics.com. And I don't think we've ever done this, but I'm going to run this voucher code so you can get 15% off. So if you put that into your order, Dog Days 2020, you can get that discount. So that's going to expire tomorrow night. And I'm sure you can find something in there that will boost your meteorology skills. Everything in there is written by forecasters for forecasters. All right, hope you all have a great Tuesday evening. We will talk to you tomorrow. Bye-bye.